All right, so in this video, we're going to use the double log model for prediction. So before we get into the Gauss-Markov assumptions, or the assumptions of the classical linear model, we're going to talk about using the double log model for prediction. So remember, for the regression, the specification is log Bitcoin, which is equal to beta 0, so some intercept, plus beta 1, some slope multiplied by the log of the stock to flow at time t, plus our error term at time t. And if you're going to use this to predict or to estimate Bitcoin price, this would give you do e to the power of all of this, e to the power of all of that. And of course, then you would get the price of Bitcoin at time t is equal to e to the power of your intercept plus your slope, and so on. So now to pull up the notebook and to go over all of this. All right, so let's actually plot it out in a scatter. So if I do x and y, this is going to be the data, the actual values. Make it a little bit transparent. This is the actual, and you can see that up in the regression plot up above. If I plot another scatter, same x-axis, which is the log stock to flow. So this is not stock to flow. This is log stock to flow. This is not price. This is log price. Then we look at the predicted values. So reg.predict, open, close. Let's make it blue. And let's make this one 50% transparent as well. And I'll label it estimate. So this is the double log model. This is the regression that we estimated. So each blue value is the estimate for that specific log stock to flow. Then the black is the actual value, or the actual data. Log BTC. Then the X label, the X-axis would be log stock to flow. So if we're going to use this to predict, let's create a new column. So we have our price, we have stock to flow. If we're going to create a new column of the predicted or estimated BTC, estimated price, let's say estimated, or we could say predicted price. Predicted price, set this equal to, in order to get an array of the predicted value for our regression, we just do reg.predict, and that would give you an array. But that is the predicted value for log Bitcoin price. To convert that into Bitcoin, you do e to the power of your predicted value. So reg.predict. And now it should have worked. Yeah, so now we have our actual estimate, or our actual prediction for Bitcoin. So let's create a subplot, a 1-row, 2-column, 1x2 subplot, where on the left it's the actual price, and on the right it's going to be the actual versus log price, actual log versus predicted log. So to do this, we'll do a subplot, PLT subplot, 1-row, 2-column. I'm going to do the first one, which is going to be the one on the left. And we're going to plot it with respect to time. So if I do this, we look at it. This is the actual price. And let's be consistent. To be consistent with what we did earlier, we'll make the actual price black. Let's keep it transparent so you can see them overlapping each other. We'll name this actual. Let's do it again. But this time we'll do the predicted price. So predicted price, and we'll make it blue. Blue just because this is what we did earlier. And the label is going to be the predicted. So you can see that you are decently off with the with your estimates. You see a huge spike in the actual Bitcoin price, whereas this model only estimated that it would be, looks like 4,000, whereas it went all the way up to 14,000, which I believe this is in monthly prices. So let's do one more. This is going to be the one on the right. In this one, we're going to do the log price, the log predicted price. I'm just going to do it like this. Copy and paste it. The only difference is we're going to do the log of the price. We're going to do the log of the predicted price. Let's make it a little bit larger so we can see it. So PLT pie plot, we're using pie plot from matplotlib, plt.figure. I'm going to say fixed size is equal to, let's say 14 by 5. It should be reasonably bigger. So here you can see that it's reasonably close for the log price with respect to the predicted log price. But what these differences in logs you can see is huge differences for the actual price itself. You can see huge differences in the actual price, whereas these may be relatively small. That translates to huge differences over here. So here you can see the spike. This was around 2014. You can see that right here, big difference. Then over here in it looks like it's the middle of 2016. That's right here. It's not that huge of a difference, but over here it translates into thousands of dollars. And this one, again, it's even looks like it's an even smaller difference, but this translates into thousands of dollars over here as well. Then this, just so you all can see it, I'm going to let's add a Y label. This is we'll put the price for the Y label. This is the one on the left. X label is just going to be the date. Then for the one over on the right, let's do log price. It's the same X label. Do the date. So now it's a little bit cleaner. And if you want to add a legend, default legend is going to go wherever it thinks best. If you want to move it off of the graph, you can do bbox to anchor command or parameter, and you give it a tuple. So remember, a tuple is immutable. A tuple is like a list, but you do the parentheses, and you can't change anything that's inside of it. Let's make it 1.35.5. Now it's a little bit cleaner. Maybe it's a little bit too far to the right. You can just play around with that. So the blue is the predicted value, black is the actual. Small differences in the log model translating to big differences into the actual price. Next video, we're going to go over the assumptions, and we'll check to see whether or not all the assumptions hold. If it does, then it's a good model. If not, then maybe there isn't a relationship, and this is just randomness. Or maybe there is still a relationship, but there needs to be another model. It's just co-integration.